Hello, this is Mr. Collier, and today we're looking at polynomial functions. Okay, so here we have an example of a polynomial function called a cubic function. It's cubic because the leading term has an x cubed, so it's called cubic. Here's what some cubic functions might look like, something like that. Okay, so in our example, we have the number of fish in a pond from the period 1995 to 2010 is modeled using this formula, where x is the number of years after 1995. Use your GDC to make a sketch of the function from 0 to 18. Okay, so we're going to do that now. We're going to graph this function. Okay, so there's the function. And you want to graph it from x equals 0 to 18. So let's on our graph do from 0 to 18 on the x max. And the y values, I'm not sure how far the y values are going to go. Let's keep it like this for now unless we need to change it. So let's graph that. And looks like we can't see anything, so I'm going to have to change the window and see if maybe y max is a lot higher. Let's try 100, see what happens. Okay, so that's a lot better if I graph 100. So let's plot the. Actually, let me just take a screenshot of that. So that's what the graph looks like. Okay, so that's what the graph looks like. Basic shape of the graph. Find the number of fish in the pond after 6 years. So you can, in this case, that means x equals 6, and the number of fish in the pond after 13 years is x equals 13. I can put an x into the formula and work it out, but I've already got it graphed, so actually let me just go to table and get the answers to those two questions. So I'm going to go back to, actually we need 13 years. So the number of fish in the pond after 13 years is going to be about 57. Maybe I'll round to 57. Okay, so we'll say about 57 fish. And for 6 years, it's about 50 fish. Okay, so that's it for that question. Next we're going to do this example of a cubic function. So a pandemic model is used where x is the number of weeks after the outbreak has started and y is the number of cases reported. So this is the spread of some sort of disease or something is modeled by this equation. So we're going to use our calculator to sketch the function. So I'm going to type in the equation. We'll go to graph, but we need the window for the x values to go up to 30. Alright, so that's going to go to 30. And the y max, looks like the y's are going to be up to 5,000 or more. So I'm going to actually try maybe 10,000. Let's see if that works. Let me try that. That looks not too bad. So that's your graph right there. You can make a little sketch of it for x equals 0 to 30. So part A. So part A, you have something like this. So it gets larger, then it kind of peters out like this. So that's x equals 0 to 30. And our y max is about 10,000, so let's label that at 10,000. Okay, so part B, number of cases after 10 weeks, and then 20 weeks. And so we can look at the table. After 10 weeks, there's 4,000 cases. So 4,000 cases. And after 20 weeks, we can scroll down to 20. we have a 5,000. So 5,000 cases. Quartic functions. So quartic functions have an x to the power of 4 in the equation. Okay, so let's take a look at a quartic function. Here's one right here. We're going to use a graphing calculator to draw that quartic function. So I need to go to graph it and type in the function. Okay, so now I've got the function typed in. I'm going to graph it, but I'm going to change my window to go from the x values go from 0 to 20 because it asked me for that. And the y min and max, I think I'm going to stick with negative 10 to 10 and see what happens. So let's try to graph that. Okay, so we can actually see the whole thing here, so that's good. So that's a good window setting. So if you were to sketch that, let me just make a little screenshot, and then we're going to sketch it by hand. So if I were to sketch that, remember I went from negative 10 to 10, and this is up to 20. Okay, and I'll just go something like this here. Okay, so that's my sketch. Find the time of the low tides. Alright, so the low tides would be here and here, well maybe right here. So we're going to find the time of the low tides. Let's actually, maybe the best way to do that is to go to table and see when the y value is lowest. So we have, seems like it's the lowest at 9 hours. Okay, so this is hours after midnight, so 9 hours after midnight would be 9 o'clock a.m. So that would be 9 o'clock a.m. Okay, looks like we have 2 high tides here during this 20-hour period. So I'm going to go to find the high tides. So it looks like we have a high tide right here at 2 o'clock a.m. And we have another high tide later on. At 17 hours after midnight, so that's 5 o'clock p.m. Okay, in the next example here, here's a graph of a quartic function. Find the value when x equals 2. Looks like it's going to be about 5. Actually, we can find the exact value with the equation right here. So f of 2 equals 2 minus 2 to the power of 4 plus 6. That's a 0. So f of 2 equals 6. So that value is 6. Find the values of x when y equals 6. So we let the function be 6. And we'll work out 6 equals x minus 2 to the power of 4 plus 6. And we'll subtract 6 from both sides. We'll get 0 equals x minus 2 to the power of 4. We'll get the 4th root of both sides. 4th root of 0 is that. 4th root of x minus 2 to the power of 4 is x minus 2. So x equals 2. Okay, write down the range of this function. You can see the lowest value, it almost looks like a parabola, but it's not quite, it's a little bit wider. The lowest value is y equals 6. So we're going to have, the range is going to be y is a real number such that 6 is less than or equal to, or so you could say y is greater than or equal to 6.